The next topic we're going to discuss is converting polar coordinates back to rectangular coordinates. So taking a coordinate that's in the form r comma theta and turning it into a rectangular coordinate that is in the form x comma y. So we discussed earlier that we have two equations that relate x, r, and theta and y, r, and theta. And those two equations are x equals r cosine theta. And we can remember that x relates with cosine just like it did on the unit circle. And our other equation is y equals r sine theta. So if we want to convert these previous polar coordinates that we were working with on the other page or the other slide, we just use these two equations to help us find x and y. So if we want to convert 5 comma pi over 4 to a rectangular coordinate, we just say what is 5 times the cosine of pi over 4 and what is 5 times the sine of pi over 4. So we know that the cosine of pi over 4 is root 2 over 2. Hopefully we still have that memorized. And the sine of pi over 4 is also root 2 over 2. So my final coordinate for number 1, would be 5 root 2 over 2, comma 5 root 2 over 2. So if you graphed 5 root 2 over 2, comma 5 root 2 over 2, it would end up in the same spot as 5, comma pi over 4. So now let's use the same method to convert number 2 to a rectangular coordinate. So we're going to use the same method. We're going to say 3 times the cosine of negative 5 pi over 6 and 3 times the sine of negative 5 pi over 6. So I'm going to draw where negative 5 pi over 6 is and fill out the triangle so I can know what the cosine and the sine are. So we know that negative 5 pi over 6 would be about right here. And since we're working with a pi over 6, we know we're working with a 30-degree angle. So this side must be 1, this must be root 3, and this must be 2. But remember, we are in the third quadrant, so both of these sides are negative. That's really important for polar coordinates, or for changing from polar to rectangular. So we know that the cosine of negative 5 pi over 6 would be negative root 3 over 2. So we have 3 times negative root 3 over 2. And we have 3 times negative 1/2 for the sine. So my coordinate would be negative 3 root 3 over 2 and negative 3 halves. Why don't you pause the video and try the next two coordinates on your own and then restart the video to check to see if you got your answer correct. For number 3, we should have had a final answer of positive 1/2, comma positive root 3 over 2. And hopefully you drew the triangle in the right spot for 4 pi over 3 and were able to fill out the sides correctly. A way to check your answer is if you have previously graphed this polar coordinate, we should end up in about the same place where the polar coordinate is graphed. So if I graphed 1/2, comma root 3 over 2 just on a normal x, y plane, that's 1, and this is 1, 1/2, and then root 3 over 2 would be about right there. So now let's go back. Okay, so now let's take a look at number 4. So hopefully we got the answer negative 7 root 3 over 2 and negative 7 halves. Negative pi over 6 is here in the fourth quadrant, and if we fill out the triangles accordingly and find the cosine and the sine and multiply it by negative 7, that is what we should get. Oh, I made a mistake. I'm sorry. Real quick, let's fix it. So this should have been a negative 1/2, and that would be a positive 7/2. There we go. All right. Moving on, now we're going to talk about how to convert a rectangular coordinate to a polar coordinate. And we're basically going to use the same, actually we're going to use the other two formulas to help us do that. So our other two formulas that we talked about earlier were tan theta equals opposite over adjacent, so y over x, and x squared plus y squared equals r squared. So these two formulas will help us find the two things that we need for a polar coordinate. It will help us find theta, and it will help us find r. Let's find r first for problem number 1, since it's a little bit easier to find. So to find r, we're just going to say what is negative 1 squared plus negative 1 squared. That will equal r squared. So 1 plus 1 is 2. 2 equals r squared. So r equals the square root of 2. And we just keep it positive because a radius should be positive off the bat. We've been working with some that are negative, and we can always represent it in a different way later. Now we want to find theta. So we have tan theta equals negative 1 over negative 1. So we need to find the angle where the opposite side is negative 1 and the adjacent side is also negative 1. So if we remember our unit circle, we know that we definitely need to be in the third quadrant because we have two negative sides. So negative 1 and negative 1. So we know that we must be working with a 45-degree reference angle. But theta doesn't equal 45. Remember, we have to start at 0 and go all the way around. And we don't want to be working in degrees. We want to be working in radians. So we have pi plus pi over 4, which would be 5 pi over 4. So our polar coordinate, it goes radius first, so root 2, and then the angle later, so root 2 comma 5 pi over 4 is our final answer. Now let's do the same thing for number 2. Write 0 comma negative 2 as a polar coordinate. All right, well, first we're going to use the equation x squared plus y squared equals r squared. So 0 squared plus negative 2 squared equals r squared. So 4 equals r squared. So r equals 2. Then we're going to use tan theta equals y over x. So negative 2 over 0. So tan theta is actually undefined. So we need to remember, where is tangent undefined? Well, it'll also help us if we plot this point. So 0, negative 2 would be down here. So we know that if we convert back to the unit circle, we're at the angle 270, which is the same as 3 pi over 2. So our polar coordinate would be 2, comma, 3 pi over 2. Okay, pause the video and try this problem on your own to see if you can get the polar coordinate for -4, 2. Hopefully you got to this point where you were able to figure out that the radius is 2√5, but when you're trying to figure out the angle, we end up with tan theta equaling -1/2. In this case, this is not a special triangle because we don't have a special triangle where the opposite side is 1 and the adjacent side is 2. So we need to end up using our calculators and taking the inverse tangent of -1/2 and making sure that our calculator is in radian mode for the final answer. So typing this into my calculator, I'm in degree mode, need to fix it. So we have the inverse tangent of -1/2. We should have gotten -0.46. But remember, 0.46 is our reference angle. So we're looking for this angle right here. So we need to subtract 0.46 from pi, because here is pi right here. So 3.14 minus 0.46 is 2.68. So our final answer is 2√5 for our radius and 2.68 for our angle in radians. Now we're going to use those same equations to help us convert polar equations to rectangular equations. So we have the equation r equals 5. So we're going to use x squared plus y squared equals r squared to change this from a polar equation into a rectangular equation, which is an equation that has x's and y's in it. So all we need to do is plug in 5 for r. So we get x squared plus y squared equals 25. And does this look like an equation that we are used to seeing? If you said yes, this is an equation of a circle, then you are right. So x squared plus y squared equals 25 is the equation of a circle. And so is r equals 5 in polar coordinate land. What that would mean is we had a radius of 5 all the way around our polar coordinates. So that would make a circle. And x squared plus y squared equals 25 would make the same circle. Now let's take a look at theta equals pi over 4. Do you know what equation we will use to help us convert this? If you said tan theta equals y over x, then you are correct. So we're going to plug in pi over 4 for theta. And the tangent of pi over 4 is 1. So now this almost looks like an equation that we're used to, but we're just going to multiply x to the other side. And we get the rectangular equation, y equals x. So what this would mean, if we were going to graph theta equals pi over 4 in as a polar equation, we have the angle, pi over 4, which is right there, and we would just have a straight line on that angle, and then it would continue down here. So that is the same equation as y equals x. So now we will work on the other two equations in the next video since we're almost out of time on this one. So go ahead and move on to the next video for the next two equations.